Here's an E92 M3 which has come in to us at Reedish Motorsport for Conrod bearing, shell and bolt replacement. It's a preventative measure, there's no problems with this car. I'll find the mileage in a minute and update it on the video, but it's just in for the preventative measure, like I say. So just put it onto the lift. Now we're just going to get the under trays and reinforcement plates stripped off so that we can access the front subframe. We have to remove all that, support the engine, and then we can get access to the sump. And here's all the genuine BMW parts for the E92 M3 Conrod bearing, shell, bolt replacement. So we've got genuine BMW shells, the 702 and 703, sump gasket, genuine BMW oil filter. There's the 16 Conrod bolts. CHF 11S for the power steering, and some power steering sealing washers because we have to take the front axle with the steering rack off of the car to access the sump. We've got the front of the suspension disconnected now. We've got the steering rack disconnected, front arms are off, and the power steering pipe works, things like that. The customer subframe is removed, and we've got our special tools on there to support the engine safely in position. And now we've got great access to the sump, so we can remove the sump to get access to the Conrod bearings and bolts. So the sump's now removed, and we've taken the oil pickup pipe off, so we've got access to the Conrods. And we're just starting on position number 1, and we've just taken the lower cap off, and we can see that there's a marking on the journal of the crankshaft, which isn't usual. There's sort of deposits on there. It should be a really nice shiny finish all the way around, but especially where the oil flow hole is, it's really got some deposits on it. You can't really feel them with the finger. The one that we've taken off, which is position 1 Conrod cap, here's the shell that we've taken out. So it has got some wear markings on there, and I'd suggest that this marking where there's a section or layer of material missing, that's probably what's imprinted itself, or likely to be on the crankshaft journal. We've not seen this before. Normally they come out and they're very polished still, but this one's got deposits from the shell onto the journal. And interestingly, we're just lifting the rod up to take the upper Conrod bearing shell out, and it is actually contracted because it's extremely tight on the journal of the crank, whereas it should stay in the Conrod as the Conrod lifts up, and it's like as if it's almost contracted in size. So we're just going to take that out and see what we find on the upper shell. So we've taken the upper shell out now. It was contracted. It was stuck on the crankshaft journal, not in the rod, which is interesting. So it's got hot, and it was very worn. Many layers gone through and onto the copper, and if you look in certain lights you can see the surface is actually starting to crack up, it looks like. So very good timing that this customer had this done as preventative maintenance. So just for the record, it's a 2008 model, 088, 089, the old bearings, I think that's the original ones, 67,000 miles. And we've also done an oil sample before we took the oil out, so we've sent that away to be analysed, and we'll see what it comes back with. And if it comes back in time before I finish this video and this job, we'll update the video with the oil sample reports, reference that sort of wear that we're noticing. So after looking a little bit more and talking with amongst ourselves, we're thinking that this sort of area that's missing some form of film or layer, it's quite possibly a heat transfer of the lower bearing shell onto the lower part of the journal. At the moment we can only see the lower part of the journal because we haven't yet investigated the top side where the rod is. So a bit like how you would if you were given give the brakes a good workout, shall we say, and then you came to the traffic lights and put your foot and rested it on the brakes, you're likely to get a pad transfer onto the brake disc. And although these bearings don't touch the journal, it's possible that after some heat cycling, that is possibly a heat transfer of bearing shell material. It might not even be any material on there. You can't even feel that with your finger, but it just is taking the imprint of the sort of section that's missing on the shell to suggest that it might be, like I say, a heat transfer of material. So that's what our findings on position number 1, which is cylinder number 5. We're just going to go through the rest of them now, and we'll also be measuring with plastic gauge, BMW's special tool system that they employ for measuring these clearances, and we'll see what the clearances are on the old shells, and then think about our findings and go from there. Well, we've carried out a clearance check on the old shells, and they were 0.038 to 0.050 in between that measurement using the plastic gauge system. So that's good clearance. And now we've got the new shell in, we've got the upper shell connected in the rod, and we've put a new shell in the cap as well, and carried out the plastic gauge measurement again a second time just to make sure there's no inconsistencies, and it's come out at the same 0.038 to 0.050. So we're quite happy the clearance is good in this position, so that is one good thing. We've done cylinder number 2 now, measured the clearance on the old shells, which was 0.050, and then here's the offending shells. This is the upper one that we're looking at, a lot more wear than the first one that we took off. This is position number 2, which is actually cylinder number 1. Let's see if we can zoom in a bit, focus. Yes, quite a bit of wear on that one, and we've also got heat transfer on this lower shell, so we've got copper on there as well, but then we've got these odd markings which are also sort of in the same pattern as what we're seeing now that the journal of the crankshaft is in BDC. And then we've got new shells in, just measuring the new with the plastic gauge, and they are coming out at between 0.038 and 0.050, so within tolerance, and the same as what we just did on position 1, but we have got those markings on the center line of the journal. We obviously need to take the plastic gauge out, but we've just got some heat transfer marks on the journal. Here's position number 3, which is cylinder 6. Plastic gauge has now been checked on the old shells, and that gave a clearance of 0.05 of a millimeter, and now on the new shell, which is 0.05 of a millimeter, so exactly the same. A little bit of marking or visual heat transfer onto the crankshaft journal, but no scratch marks, nothing that you can feel with your hand. And then the bearings that came out, a good amount of copper up on the upper shell, and you can also see the layers over there that have been worn through, and the lower shell, yeah, good amount of deposits coming off of those, nothing too serious. The worst one has so far been position number 2 on the upper. Position number 4 is now done, which is cylinder 2. That old clearance checked out at 0.05 millimeters, and the new clearance also checks out at 0.05 of a millimeter. Little bit of tiny bit more heat transfer, but not much on the visual sort of heat transfer on the journal. And then coming over to the shell, cylinder 4 upper, again good copper wear showing, and various layers of material there, and a little bit on the lower side. This is the one that's in the cap, but no real copper apart from the very tiny bits on the edges. We're on position 5, which is cylinder number 6. Plastic gauge has now been done on the old shells, and it checked out the clearance was 0.05 of a millimeter, and now also on the new shells it's exactly the same, 0.05. Little bit of marking, visual heat transfer mark on the journal, no scratches, you can't feel this with your finger, the clearances are good. And then the shell where the old shells are showing good breakup starting on the lower cap side, and then the upper one is through to many copper layers showing. We're now on position 6, which is cylinder number 3. We've got small heat transfer marks in the center of the journal, and we've done the clearance check on the old shells, which were they were actually bang on 0.050 of a millimeter, and then clearance with the new shells in place, which is what this plastic gauge is now looking at, is between 0.038 and 0.05 of a millimeter. Here's the old shells for reference. So the lower one that goes in the cap is here, and then this one with the copper markings on it is the upper one that goes in the rod. We're on position 7 now, which is cylinder 8. Similar sort of thing, visual heat transfer marks, and we've done the measurements of the old shells and the clearance with the plastic gauge system. The old shells we're measuring clearance of 0.05, and the new is also 0.05, so same consistency even with the new shell. That's in at the upper. And then just having a look at the old shells. A lot of copper on this one. This was contracted, it was tighter, it actually stayed on the crankshaft, didn't come out with the rod moving up, so that one was a bit harder to get out, but this obviously got quite hot or warm. And then the lower one, which is the right hand side one that's in the cap, showing good markings as well where it's had layer material coming off. Here's the last one, which is position 8, cylinder number 4. More heat transfer marks on the crankshaft journal on this one. The old clearance with the old shells measured at 0.05 of a millimetre, and so did the new shells. The plastic gauge measurement, which is still in situ, and then we'll remove that now. But that's just showing the new shell clearance, which we've checked is 0.05 of a millimetre. And then looking at the old bearings, pretty much the same as most of the other ones. Copper on the upper side, and then just general wear markings on the lower cap side there. So all clearance is checked out well within BMW's tolerance, and now we've got new oil O-rings on the pickup pipes, and then a new BMW sump gasket, and now the sump's just been positioned on. That's going to be torque checked and then cleaned up. The rebuild's almost finished. We've now got the front subframe back in position, the steering rack's on, these joints for the front arms are connected, and that's been done in normal position, so not to stress the rudders. Power steering hoses are back on, steering shaft's going on next. Then we'll be filling with engine oil, changing the oil filter, putting power steering fluid in it, and attempting for a start. The rebuild's complete now on this E92 M3. Everything's back together. We've done heat cycle and checking for any oil leaks before all these under trays go back on, and we're happy with that. We've done very slight brief road test under very little load conditions whilst we go and just start putting some miles on it, and then advise the customer to do a steady 500 miles. Under trays are back on, everything's torque checked and paint marked, and we're quite happy. Oil level's been checked and topped up, now it's got to operating temperature. So that's the mechanical work complete. And there's the car finished. Now we've done some brief road testing on the vehicle just to put some gentle miles on it. We're quite happy with everything, and now we'll pass over to the customer with instructions of 500 miles for the basic bedding in procedure. And that's been Conrod bearing shells and bolts, all using genuine BMW parts here at Reedish Motorsport.